You type a specific web address into the browser on your phone, hit go, and the page appears instantly. But in that fraction of a second, your device is actually firing off a request across the globe, trying to pull a specific file from a piece of hardware it has never interacted with before. These two machines are complete strangers. They might be running entirely different operating systems, and they must coordinate this exact data exchange through the unpredictable, highly noisy traffic of a global network. What keeps this from collapsing into digital static is a strict suite of rules called application layer services. Think of it as a universal translator and a traffic cop rolled into one. If we didn't have this agreed-upon framework sitting exactly between the physical hardware and the software you actually see, the seamless web we rely on would simply stop. To get a file from a remote server, your browser first needs to know exactly what it's looking for. It does this using a specific string of characters called a Uniform Resource Identifier, or URI. This diagram breaks down a URL, a specific type of URI. The bottom section shows how a URL provides the exact network location of a resource while also specifying the protocol required to reach it. That URL is perfectly formatted for a human to read, but the physical routing hardware moving your data across the world only understands numerical IP addresses. To bridge that gap, your browser queries the domain name system, or DNS. It takes that human-friendly web address and translates it directly into the machine-routable IP address of the target server. It acts as the master directory for the entire internet, letting us navigate with words while the machines quietly handle the complex numerical routing in the background. Now that your browser has the server's exact IP address, it has to physically link up with it. It does this by establishing a TCP connection, which locks in a dedicated, reliable pathway between the two machines for the duration of the data transfer. The connection relies on specific digital docking stations called listening ports. Your device opens a randomized, high-numbered port on its end and plugs directly into the server's standardized port, which is usually port 80 for regular web traffic. Looking at the top right of the schematic, we can see exactly what happens next. The browser fires off an HTTP GET request through that open socket, asking the server to hand over the index.html file. Along the way, any firewalls or intermediary routers will inspect the packets passing through to verify they belong to this authorized, ongoing TCP connection. Once the web server receives the request, it gathers the data and sends it back. We see that on the bottom left here, a standard HTTP 200 OK response, carrying the actual HTML payload. This highly orchestrated call and response protocol is the only reason your screen can instantly render a graphical, interactive web page instead of a wall of broken code. But pulling up a web page is just one type of conversation. HTTP is only a single language operating within the much wider application layer. If you need to upload a large corporate file to a central server, HTTP won't cut it. Instead, you'll use FTP, the file transfer protocol, which relies on port 21 to control the session and a separate port 20 just to move the data. Sending an email operates on a completely different set of rules. It relies on SMTP to push the message out across mail servers, and protocols like POP or IMAP for the recipient to pull it down. There are even protocols constantly running in the background. SSH provides secure remote access to networking devices, while DHCP automatically hands out IP addresses so your computer can connect to the internet in the first place. Thanks to these agreed-upon standards, a single computer can juggle a web browser, an email client, and a background file transfer all at exactly the same time, without crossing a single wire. This invisible, multilingual application layer translates raw physical connectivity into functional communication, keeping billions of diverse interactions perfectly ordered and instantly accessible.